Good morning, guys. So, today we are going to start a very good topic as per me. Why I'm telling you as per me is because I don't know why most of the guys find the next two chapters, that is ray optics and wave optics, very tough. But it is actually a very easy topic, and it is all based on what you say as a presence of mind, right? And rather than theory, it is more what practical or most of the problem are application based problems, right? And it is pure theory based, or theory section is very less, but it is mix of theory as well as numerical, right? So actually this chapter is a continuation of our EMWs, right? EMWs was very easy because as you saw, we just completed the chapter within 2.5 hours, and I asked you guys to do the rest of the things. Remember, I asked you guys to learn about entire spectra regarding our infrared rays, etc. That can be studied by yourself. It's very easy. Okay, so now we are starting the chapter optics as per our NEET JEE, right? Because in NCERT, optics is further divided into two chapters, which is ray optics and wave optics. And actually this is based on the single branch of science, and this optics is the branch of science which studies light, right? And study of light is known as optics, and optics are further classified into ray optics and wave optics, right? And we are studying both of them in two separate chapters, but in most or many of the NCERT books, JEE NEET examination books or materials, both of the chapters are added and just written as a common heading as optics, right? Now, the previous chapter we have learned, or I just told you about energy spectrum, right? Electromagnetic spectrum, right? And in that spectrum, we told about visible light, right? And we told that it is around 400, it's 4000 angstrom, 4000 to 8000 angstrom, right? Earlier I think in your book you would have learned in nanometers, okay? So 4000 angstrom to 7000 around, but nowadays it is usually taken as 8000 angstrom, right? Wavelength light or wavelength rays are known as what? Visible light. And in the two chapters of optics, we are going to deal with entirely with visible lights, right? So what was, or anybody asks you what is ray optics, right? And the other is wave optics. What is the difference between them is, in ray optics, when you consider the visible light's wavelength, the object or the body which you are going to see or which you are going to study, right, that body has size greater than the wavelength of visible light, right? The branch of science, right, or branch of optics which deals with the conditions or the sections where the object on which we are going to study is having wavelength much more greater than wavelengths, or a much more size more than the wavelength of visible light, is known as ray optics. I'm going to repeat it. I made a small mistake, I think, when I was telling. So what is ray optics? Branch of optics which deals with light itself, but the body on which we are studying, or the images we are going studying, that body is having size larger than the wavelength of the light. Whereas so the opposite will be the waves, right? It is not less than wavelengths, it is similar to wavelength, that is size of body is somewhat equivalent to the wavelength of light. So it is very easy to understand. See guys, this is larger body. See, when you are using torch, right? So you use torch, right? So this is our torch, oh, right? Right, and you gave light, right? It, and you saw this object, say A, right? So the study where, or the branch, this is entirely on the topic optics itself, right? Because we are dealing with light. Now this light fall or fell on this object and we see the image. This part comes in optics. Clear? But the light rays, right, it actually can it has undergone diffraction. This is called diffraction. I will tell you about in the next lecture. I can say there is a deviation of light waves, or I am actually dealing with small particles, how the particles are going to act inside that waveform. Those branch comes under wave optics. This section where you see this object, right, this object is very large when compared to this light source wavelength, right, that comes in what? Ray optics. Right, wave optics deals with interference, diffraction, etc. So like if I know what and all are to be known about ray optics, basic things. Ray optics, as you can say, the main word which comes is ray. So what is a ray? Right, is actually a light source itself, but that light source just travels in a straight line. So this becomes a ray. A light source which is just one line, right, and on all the light rays, or light always travels in the straight line, but out of this, when I just take one of the segment or one line, that becomes a ray. And collection of lot of rays, right, that is known as beam. So when you use a torch to see something, so what you get is known as beam of light. It's not called ray of light, it is called beam of light, right? So that's why laser etc. is usually called a laser ray, because laser which you see is actually one ray, but it can be more than, but usually it is better to understand the difference between ray and beam. You can say ray is just like our laser beam, beam is just like our torchlight. Clear? So collection of ray is known as beam, and single straight line light ray, right? Clear? So let's move on. Now this topic, reflection, which we are going to take next, is removed from your 2020 syllabus, CBSE, but not from NEET. So I will be taking that section, but since the topic has been taught already to you guys in the 9th class, I will speed it up, right? So what do you mean by reflection? So when you will have a reflect surface or reflection surface, right, there will be an incident ray like this, let's say that is I, right, it will be reflected back, right? So and you have a, I will draw a line, straight dotted line. This is known as normal, right? Normal N is the line which is perpendicular to the mirror, right? This is our mirror. Let's say this is our plane mirror, right? So normal is the line which is perpendicular to the mirror at the point of incidence. This is the point of incidence, right? From point of incidence, due to this mirror, it is getting reflected back, and this line is the perpendicular line which is drawn to the mirror at the point of incidence. Clear? And you have learned this angle is known as angle of incidence, and this RS angle of reflection. And you have learned about the first law. Remember, angle of incidence is equal to angle of reflection for any reflecting surface. It can be either a mirror, any concave mirror, convex mirror, whatsoever, any reflected plane you are having, angle of incidence is always equal to angle of reflection. This is the first point, right? And what is the second law you have learned? The incident ray, the normal and the reflected ray lie in the same plane at the point of incidence. See, at the point of incidence, the incident ray, the normal as well as reflected ray, all are lying on the same plane. That is our second rule. I am not going to write it. You hear it and write it. Now, what happens if this condition? I am drawing in another figure, guys. This is our mirror and the beam is like this. It meant to be straight and perpendicular. I don't know why it is not straight. I hope this is straight. I think there are figures for drawing like, no. Yeah. Sorry. Yeah, okay. Now it's straight, right? Wow. Now, very happy with it. I'm no discovering a lot of things. Now, anyway, so this is our incident ray. right? So what is happening here? Here the angle of incidence is 0, right? Why? And what is angle of incidence? Is the angle between what? Incident ray and normal. Yeah. Here normal is also, sorry, I saw V, right? Here normal is also in this direction, right? So I can not the direction, normal is also this one. So the angle made by the incident ray with the normal is how much? 0. That's why I wrote angle of incidence is 0. Now when this happens, the reflected ray is also in here. This is our reflected ray, right? So I can say both angle of incidence and angle of reflection is 0 in this case, right? That is when the incident ray falls normally on a plane of mirror, then the angle of incidence, the angle of reflection is equal to 0. Clear? This and all you have learned, right? Now we'll go for the next section which you have not learned little bit, but we'll learn it in a broader way. Okay, that is what is the or how is actually an image is formed in the case of plane mirror, right? So plane mirror case, guys, this is actually not much in as per your syllabus, but I am taking it because we don't know regarding the NEET and JEE how it will be. Okay, now, ouch. Now let's say, is it black or no? I meant to be straight, I don't know. Okay, but they, is there a line? No, I take this one as a, okay. Sorry. Now this is plane mirror. Now it became very bad to look. Okay, anyway, sorry. Now this is our point source. Okay, and this is my eye. Let's move on, right? So how would I draw about images in a plane mirror? So let's, okay, let me take another figure. No, this one. Okay, I want to draw the mirror straight. Okay, oh, the color became black again. Sorry, it's okay. So this is the object, say this one dot, right? This is object O. It's a point object. This is your eye here. Okay, this is you. You want to see the image of this object O. Okay, so what you know about it is, and what you have learned is how you see object, or how do you see the an object is existing when the object's reflection is appearing on your eyes. That's how you see an object, right? So similarly, if you want to see an image, what you expect is the image is formed where the reflected point is meeting, right? So see, this object is giving or inside in having incidence like this, right? So this incident angle here is producing here reflection and a reflection here. So this reflection, both of this reflection are not meeting your eye, right? Clear? I hope you understood. You will not be able to see an image as per this, but so what you see is, so for you these two reflected rays appear to be coming, right? It is not coming, it appears to be coming from another source like this O dash, right? It appears to be coming from inside the mirror. Clear? Right? And that is, these reflecting waves actually don't meet ever, right? So you have studied that image is always formed where the reflection is occurring, right? And reflection must meet somewhere. So how can I say that image is formed? So that means you see that the reflected, or you feel, right, that the reflected waves are not from here. Things are actually something which you have learned in your 9th class, I believe, right? So the O is the object, right, and the reflected wave also you have seen, and O dash is the image. Sometimes O dash can be even written as I, Right. Sometimes in the book it is object is written as O and image is written as. Now look at the picture, guys. You see the image O dash. Right. That is the you feel that the light rays are coming from where? Image. Clear? I hope you understood. Right. So you feel that the reflection is from here. Clear? Right? So that means actual image I am not getting. The image I got is known as virtual image. Is it an actual image? No. Actual, the reflected rays are not at all meeting. I feel that the reflected waves are coming from this point O dash. Right? Clear? Right? So you feel that this is the image and I am seeing the object. You see an object or the image only from or object is seen if the light rays are incident on it and it reflects back to your eyes. Right? So you feel that this image is having or formed by the reflected rays or meeting of the reflected rays which never happened. Clear? So the image which is usually formed by a plane, usually always formed, is a virtual image. Right? And another point, if the object is at say x centimeter from the mirror, then the image will be also at x centimeter from the mirror. Keep that in mind. That is always, and object will be right. If the object's distance has to be taken in perpendicular way, similarly the image will be also perpendicular way. I will tell you with an example. Right? So I hope this much is clear. The object is always, object as well as image are equidistant from the plane of mirror. Clear? So if I draw, let's say, a mirror like this, a point source like this, so this is at a distance d, then at the distance d inside the mirror you see its image. Clear? I hope this is clear. And both will have the same size. In the case of plane mirror, distance of the object and the mirror, if it is d, then the image and the mirror will be having the same distance. Similarly, the size of the object, if it is h, similarly image will be having the height or size as h itself. Right? If your plane of mirror is like this, right, and your object is here, then where will you place the image? See, you have to draw a perpendicular to the mirror. I hope this is perpendicular. Alright, in that perpendicular line only your image or this object's image lies. Let's say it is here. This is O, this is O dash. If this is x distance, this is also x distance. Clear? Now let's take another example. Let's say another example, guys. Say this is our mirror. Okay, and let's say your object or the object is here O, right, and you're asked what will be the, and it is at 2 centimeter, and let's say this is x-axis and we are drawing a y-axis like this. This is minus y, right, and the mirror is making 45 degrees with y-axis. This is given. You are asked what is the position of image. If such type of questions are asked, always draw, if you're given the object's position, draw the image, guys. If this is object, so draw perpendicular. Okay, let's take a perpendicular like this. With a 45 degree doesn't look like a 45 degree now. So let me change a little bit, guys. Take my paper. 45 means it should be exact now. So now it does look like a 45 degree. Okay. Now draw perpendicular from object. Right, and this distance, see, this angle is 45 degree because this is 45 degree, this is 90, then obviously this angle will be also 45 degree, right? So this becomes a right triangle. So this is x, means so this side, this angle and this side angle are equal, so this will be also x, right? So if this is 2 centimeter, so what should be the value of root x? It should be root 2. Why? X squared plus x squared is equal to 2. So 2x squared is equal to 2. So x squared plus x squared is equal to 4, 2 squared, sorry. So 2x squared will be 4, so x will be root 2. So you will get the value of here, this value as root 2. Let me rub here and I will write it etc as exactly as root 2, right? So this is root 2, this is root 2. Now this angle also will be 45 degree. If this is 45 and this is 90, so obviously this angle is 45 degree. So that means this side and this side should be equal. Let me take another color, you guys might be having the difficulty here. I meant this side and this side, because the angle are equal, right? So I just wrote this as root 2. So that means this is also root 2. If this side of the triangle is root 2 and this side is root 2, then obviously this side should be 2. Clear? Right? Now you found the position of image. This is our image. So what is image position? In x-axis it is 0, in y-axis it is -2. Clear? Easy, right? Now let's do another section, guys. Now okay, I want to confirm one other thing. Suppose this is our mirror, and this is a man with a 2-meter height. I'm just giving an example. Then and it is at a distance 4 centimeter from the mirror, then the image will be also at 4 centimeter and the size of the man or image will be also 2 meter, right? Clear? Now the next section is, suppose, and this is a proof thing, right? Suppose h is the height of the object, right? What should be the minimum length of the mirror so that his image will be properly fully seen? Minimum length. Maximum length is object, except that is, suppose this is a man, the mirror can be of any length, right? You can see the image here itself, sorry, right? But the question is, what should be the minimum length of the mirror so that his image can be just seen? So that if the length of the mirror goes below to that size, you can either see your head, or you will not be able to see your hand, like that. Clear? Right. So how would you do this? Okay. Now I'm telling the answer before itself. The minimum length should be at least it should be half of his height. Mirror's height should be minimum half of his height. Okay. Now we are going to prove it. So first, let's take a mirror. Okay. And this is you, this is your head, this is your eye, and this is your feet, right? So let's say this is the object or your distance from the mirror. Clear? Right. Now if this is the distance of the object or your from the mirror, then your image will be also equidistant. So this is h dash, this is I dash, and this is f dash. Clear? This is your M mirror. Clear? Now you are seeing the image, right? You are seeing your image itself. So if I will take another color, guys, let's take okay. Now you are seeing the image here. So that is, you are feeling that the reflected ray is coming from h dash, that is head section, and from the feet section, like this. So that means your eyes are seeing that the light is coming from here, right? From H dash and F dash, right? But actually what is happening, actually the light rays, I will take another color. Well, let's not take that one. Okay, red. Actually the light rays is coming from here. The object is here, right? This is head, right? And this is actually the reflected beam from here. But you feel that the reflected beam is coming from here. Similarly, from feet the incident ray is coming over the mirror, right? Then it is getting reflected back here, right? But you feel that it is coming from here. That's why you see an image H dash F dash here. This much is clear, right? So let's make a straight line like this also to E dash, right? This is L, this is L. Let's say this is X and this is Y. That is, let's say A, B is X and B, C is Y. This much clear, right? Let's write over here. Okay, now let us consider, okay, again we have to see this triangle. Oh, that's why. Now let us consider the triangle E H dash E dash and triangle E A B. Okay, let's draw the triangle here itself, right? Triangle is like this. This is H dash, this is E dash, this is A, this is B. What was the distance? Let's say this is X, this is E, right? This L, this L. Now the triangle E H dash E dash is similar to triangle AEB. Why? Angle E is common for both these triangles, right? Similarly, this angle is 90 degree and this angle is 90 degree. So two angles are equal. So I can say ratio of their sides are equal. That is H dash E dash by AB is equal to E dash by EB. Clear? Now what is AB? From the figure it is X. So H dash E dash by X is equal to what is E dash? That is its length. That is 2L divided by what is EB? That is L. So LL cancels out. So I can write H dash E dash is equal to 2X. Right? Let's draw that or write it in the figure. This is H dash E dash is 2X. Clear? Now similarly, let's consider the triangle, the lower triangle. Ouch, this one. Oh, okay. Why it is happening like this? Okay, now what is the triangle? E dash F dash. Okay, I'm going to draw that triangle in below. Okay, let's draw it like this. So this is E dash. This is, there is a middle point, that is BC. This is Y. This is L. This is L. This is E. And this is F dash. Right? Now for this triangle, what can I say? Same, right? Triangle E dash, F dash and triangle EBC are similar. So I can write E dash, F dash by BC is equal to E dash by EB. Right? Now what is BC? Y, right? So E dash F dash by Y is equal to what is E dash? 2L divided by L. LL cancels out. So I can write E dash F dash is equal to 2Y. Now let's write this one in the figure. What is E dash F dash? It is written as 2Y. Now what is the length of the minimum length of the mirror which is required from the figure C? From here, from A to C, that is the minimum length required, right? That is X plus Y. So mirror's length which is required is, let's write M is equal to X plus Y. Now what is the image size? It is 2X plus Y, and you know the image will have the same size as the object. So the height of the person is what? 2x plus 2y, or I can write 2x plus y, or what I can substitute as 2 into m, or I can say m is equal to person by 2. That is, the size of the mirror should be at least half of the height of the person. That is, if the height of the person is h, the mirror will have or should have minimum half its size, so that entire h height of that object can be visible as an image in the mirror. This much clear? All right. Let's see, guys, when I'm doing the problem, you would have seen a lot of e dash, b dash, etc. It will be confusing. Once look in the video, understand it, then write it on the paper and try to do it by yourself. It's not that complicated. Clear? Now this section, or this h dash, y dash, or half of the height, is something very, very important, guys, because keeping that in mind, many application based questions comes up. Okay, now let's move on with the next question. Now this is a little bit different, guys. This is our mirror, all right? Ouch. Now let's redraw it. How to take how was the object taken? I don't remember. Oh, this one, right? Okay. This is our mirror. Okay. This is you. Let's say you are equidistant from a wall. Let's darken the wall. This is a wall, right? Let the wall be A, B, right? You are equidistant, or you are just in middle between the wall and the mirror. Okay, and you want to see its image, let's say of equal height, right? So this will be at a height distance 2x. So this is the image. Okay, this is A dash, B dash. Okay, so you want the image like this. So what will the eye feel? Your eyes will feel that the light rays coming from here and from here, right? You will feel like this, but actually the light rays are actually coming from the object. It is getting reflecting, right, from the mirror, and it is falling on your eyes. Similarly, light is falling on the mirror, it is getting reflecting into your eyes, but you feel the light rays are coming from the back side. Clear? Clear? Right, now that means, moving on, how would I find what should be the minimum distance of the mirror so that the I can be able to see the image, right? So we'll do the same process, guys, right? Let's first name it. Okay, let's take another color. This, let's say P, Q, no, okay, let's make it as R because I require a middle point here. Okay, from you, so let's make this one as Q. So you have P, Q, R. Let's say this distance is D, this distance is D dash, this is X, X to X. Okay, so this is your wall, this is wall's image. Clear? Now let's take the triangle. Okay, let's make UO. Let's take this triangle, this C dash. So you will take the triangle O A dash C dash and OPQ, right? OPQ, this one and this triangle, right? You will feel that these two triangles are equal, right? So that means A dash C dash by PQ is equal to OC dash by OQ, right? Or I can write A dash C dash by PQ can be written as D, right, is equal to OC dash by, or I can write OC dash as 3x divided by x, right, 3x because 2x plus x, right? That can be written as A dash C dash is equal to 3D, right? So let's make that A dash C dash is equal to 3D can be written here. Clear? Now let us take the below triangle, right? Below triangle is OCB, OC dash B dash and OQR, right? And you will see C dash B dash is equal, or C dash BR by QR, C dash B dash by QR can be written as OC dash by OQ, right? That is equal to 3x by x. Look into the figure, guys. You can get it from here itself, right? So because this is equal, because both the triangles are similar, so C dash B dash is equal to 3D dash, because OQ is D dash, x is cancel out, so 3OQ is 3D dash, right? So in the figure also you can write, right? So from the figure we know D plus D dash is the size of the mirror, right? Whereas if you look in the figure, the wall's height will be what? 3D plus 3D dash. Look into the figure, guys. My pick has been gone, so I am just writing from here. So the wall's height is 3D plus 3D dash, whereas the mirror size is D plus D. That means I can say that wall is thrice the size of mirror, or I can say mirror should have minimum the 1/3 the size of wall, so that the wall can be fully visible to your eyes. This much clear, right? Now similarly we can take another problem, guys. Suppose let's say you have a mirror like this, okay, and you are having a point source here, and you as a person are standing here, and you are now able to see the image of the source here, right? So your question is from where to where, right? For how much distance, that is if you are walking in this direction from here, right, for how much distance the image of the source will be visible to you, or to do what maximum stretch the man can see the image of this source. Clear? Let's the source be S. Clear? Right? How will be able to do it? Actually, this is application of the same earlier process itself. So this is your person, or this is the person, right? So this source image will be equidistant from here. So let's say this is S dash, right? So let's say the source is at the distance D, then this is also at distance D itself, or the image. Clear? Right? Now the source will have incident ray, right? Now its reflection will be in this direction, right, which appears to be meeting at this one. That's why the image is there. Clear? So this is reflected ray. So from this range to this range you can see. Clear? Right? Now let's say let's change the verb here, because I want to use, or I can say this is length L by 2 and this is L by 2 length, like that, because let's say the source is kept at the middle, just middle to it, right? So I hope you have to find this much distance. Clear? Now how would you do it? Right? Same. See, between I will take some points. Let's name it. This is P. Oh, I don't know why it is not writing. Let's say this is Q. This is R. Right? Clear? Let's say this maximum point is A and this maximum point is B. right? Between A and B, only this person can see, right? So let's take this midpoint, right? Let's say this point from where the man is starting, this one as C dash. Clear? Let us extend from source to this point. Let's say this is C dash. This much clear? Now I'm going to consider the triangle A, C dash, and what is the image? It is S dash. Right? So let's take the triangle separately. So while I'm drawing, some of the sections are getting missed. It's okay. This is A, this is C dash, this is image, this is P, and this is Q. Right? Let's remember. Okay, some of the things I'm just see, this is a particular question. Some of the things I have not told. Okay, I told you, let's say this distance is D, right? So this distance is D, right? And say suppose the person's this root's distance I didn't give you, right? Let's say this is also D. So this entire distance will be 2D. This is supposed to be mentioned earlier, I'm sorry, right? I'm just giving an application based question. Okay, so let's say from Q to C the distance is 2D, right? So write it here, this is 2D, this is D. Clear? So again, similarity of triangle AC dash by PQ will be S dash C dash by S dash Q. Or I can write AC dash by L by 2 is equal to 3, right? Or I can say AC dash is equal to 3L by 2, right? AC dash is 3L by 2. So this distance 3L by 2, then if this is an ideal condition, so this distance should be also 3L by 2, so that the total distance for which the person can go is 6L by 2, sum of it, so that I can say it is 3L. Clear? Right? Today guys, I have planned to take only this much topic, so last 3 minutes I want to have a small talk with you guys. So first of all, you can understand ray optics, half of the portion is something which you have learned in your 9th class, so it's not that much harsh until and unless you don't study it properly. You have to regularly study the ray optics. It's much more difficult than I would say compared to electrostatics. It is tougher, but compared to our current circuits, etc., capacitors of resistor circuits whatsoever, that section it is much more easier, but wave optics is much more tougher than ray optics, so you have to regularly go for it. And this chapter carries a lot of marks guys. Ray optics and wave optics carries a lot of marks in both NEET JEE KEAM examination or in the CBSE board examination. Okay, now another thing which I have to talk about is I have planned for the 1 hour classes which we are going to have from Monday, or you regularly have on Monday. On Monday classes, for 1 hour class, always study the current portion I am going to take. Suppose in Monday, the questions I would be asking will be from chapter AC as well as from ray optics, that is this video classes question will be asked. Okay, so AC should be thorough, as well as along with it you have to study what to this half an hour, sorry, 45 minutes video classes also. Okay, because I know our biology ma'am or as well as your maths ma'am, I believe, are asking you separately questions, so I don't want to burden you again. Okay, but I want you guys to regularly study. So what I will do is, on the Monday classes, I will ask Viva questions, just like treat it like a Viva question itself. I have already made names, or I have written the names in the sheet, and according to the answers you guys are giving, or I will mark them, right? And I will send you to the principal, or straight away I will send to your biology ma'am, and she will send it to your principal. Okay, from that section I can understand if you guys are regularly studying or not. Okay, I believe you are writing the exams truthfully, but I want to know if you are actually practicing it. Okay, so remember, this Monday you will be having a class. Along with it, you will be having a Viva session from chapter AC and what the current 45 minutes video, that is of ray optics. Okay, so be prepared guys, it is very important. Okay, you can expect the same with your chemistry session also. Okay.